Hi, now I want to continue to the last question for the design operation. Okay, this question actually from the last semester, semester 2, 2019-2020. Okay, we take a look this question. Okay, figure 3 shows the transfer curve and the respective VGS line of a drain feedback configuration employing a particular E MOSFET. Okay, number 1, without changing any value derived from figure 3, show how the same E MOSFET can be connected in a voltage divider configuration when R1 equal to half of the R2, and then use the standard resistance values for all resistance. Okay, question 2, print the appendix 4 and sketch the respective voltage divider configuration VGS line in appendix 4, or you can draw the transfer curve as shown in appendix 4 and then draw the VGS line for the voltage divider configuration. Attach this graph together with your answer. Okay, number 3, determine the correct equation for the transfer curve. Okay, let me explain about this question. This question asks you to design a voltage divider configuration, okay, by using the information given in this graph. Okay, however, this graph actually is derived from the drain feedback circuit. Okay, it's shown here from the drain feedback. Okay, means that you just modified this circuit, but you take the given value from the drain feedback. Okay, and then question number 2. Okay, once you get the VGS line, okay, for the voltage divider, okay, draw its line on this graph, okay, to show that by using the same E MOSFET, you design another circuit which is voltage divider. So this graph should has two VGS line. One, the oldest one, which is from the drain feedback, and the new one that you find which is from the voltage divider. Okay, and then lastly, determine the correct equation for the transfer curve. Okay, means that, okay, what is the equation from this transfer curve? Okay, now we go to solution for the number 1. Okay, now from the graph, okay, we take out all the information given here. Okay, can you see its value here? 13, VGS equal to 13, and ID equal to 12. On the red line here, okay, this line is a VGS line from the drain feedback circuit. Okay, the original line here, and then, okay, from this line and from the transfer curve line here, you can find the Q point here, Q point. Now we get the VGSQ. Okay, so its value is VGSQ equal to 6.25 volt, and for the IDQ is 6.25 milliampere. Alright, okay, means that, okay, this is the two information that you obtain from the graph. Okay, how about information from the line? Okay, we review here. Okay, how to get this line, the VGS line from the drain feedback. So sketch here your drain feedback DC circuit. Okay, when you sketch here, remember that do not put the RG here because RG is already short circuit. Okay, then from this circuit, actually we get the equation VG equal to VD. And then, so VD, what is VD? Now, VD, we get VD from this loop. Okay, from VD, RD until VD here. Okay, now we go for the KVL for the VD. We get negative VDD plus IDRD plus VD equal to 0. And so, VD is VDD minus IDRD. Okay, so the important equation now, which is VGS. Okay, because we want to find this line. Okay, the VGS line. We know that VGS is equal to VG minus VS. And for this circuit, VS equal to 0. Here, okay, VS equal to 0. So here, VS equal to 0. So it become VGS equal to VG. VGS equal to VG. And we know that because of VG equal to VD, so insert here VG equal to VD. So VG become VDD minus IDRD. Okay, from this equation, normally we want to draw the straight line. You have to find two plotting point. Okay, two plotting point. By inserting VGS equal to 0, then you calculate this equation, you get ID equal to VDD over RD. Means this point is here. Okay, you see VDD equal to RD. Then for the second point, when ID equal to 0, substitute in this equation. Okay, so we get VGS equal to VDD. So this is the VGS equal to VDD. So you know that now the VGS equal to 13 is actually VDD from the circuit, and ID equal to 12 here is actually from the circuit VDD equal divide by RD. Okay, now from this information we get, okay, so from this value, so you can find the RD value because you already have VDD is 13, and then you calculate here the ID. This is ID. Okay, ID is 12 milliampere, and we solve the RD. So the answer is 1.08 kilo ohms. Find its standard value. We get RD equal to 1 kilo ohm. Okay. Now we go to another step. Okay. Okay, you just get value. VDD is 13. Okay, VDD is 13, and also RD. Okay, from the drain feedback. Okay, use this value in the voltage divider. Means that you have to find another value for the R1, another for the R2, and also for the RS. Okay, because the question asks you not to modify any value from the graph. Okay, remember that. So again, we find the VGS equation for the network. So the VGS now, we find from the VGS equal to VG minus VS. Okay, for the voltage divider, we can get VG here from the VTH. Okay, VG from the VTH. And the VGSQ here, okay, we already get from the graph. And also the IDQ. Okay, remember that? VGSQ. We have VGSQ here. And IDQ. Okay, from the graph. So we use the same value here. Now, we want to find the RS. Okay. Okay. However, you need to find VTH first. Okay, so we go to VTH, means we want to find the VG. use the voltage divider formula. Okay. Okay. Again, the given information now is R1 equal to 0.5 R2. So insert here or replace the R1, okay, and solve this equation. So you get Vg equal to 13 R2 over 1.5 R2. Okay, this Vg answers, it still has value for R2, cannot be solved, okay, because we don't know what is the R2 and what is the value for the Vg. So the rule of thumb here, for the R1 and R2, okay, in voltage divider, actually you can choose any value that it is in range in mega ohm, okay, by considering the correct ratio. Okay, so here I take the R2 is 2 mega ohm, okay, and R1 it become 1 mega ohm. Okay, I must use this ratio because it's given here. Okay, R1 must equal to 0.5 R2. Okay, so when I got this value, I insert into the Vg equation. Okay, so now I get Vg equal to 8.67 volt. Okay, therefore now we has this equation. Okay, insert the VGS 6.25. Okay, this is the VGSQ, the Vg 8.67 volt, and then the ID. Okay, now we get the RS is 387 ohm. So find a standard value RS equal to 390 ohm. Okay, then we go to solution number 2. Okay, so for the solution number 2, we sketch the VGS line for the voltage divider. Okay, so new equation for VGS voltage divider is VGS equal to 8.67 minus 390 ID. Okay, remember that this is VTH that we calculated earlier, and this is the RS. This is RS that we get from the calculation. Okay, now we get the plotting point. Okay, just insert any value, okay, for this equation. Okay, first ID equal to 0 and we get VGS is 8.67. Second is insert ID is 12 milliampere and we get the VGS is 4.68. Okay, so I plot, okay, this point. Okay, first is for this point here. When ID equal to 0, VGS is 8.67 volt. The second point, okay, I choose ID equal to 12 milliampere and the VGS is actually around 4.68 here. Okay, 4.68 volt. So this is the 2 point. Then I make a line here. Okay, the green line here, I draw a line here. So this is a new line for the voltage divider. Okay, now we go to the last question, last part. The equation of the curve is given by, okay, the last question asks you to find equation for the transfer curve. Okay, this is E MOSFET transfer curve. Okay, the general equation. So VT is 3 volt from the graph. You see, from the graph, here is VT. VT is 3 volt. Okay, and then for the K here, okay, K equal to ID on, okay, divide by VGS on minus VT squared. Okay, how to find value for ID on and VGS on? Okay, ID on and VGS on can be obtained by choose or you pick from the graph. So you can choose any correlated point. Okay, this graph is actually you may find any point here. If you choose here, if you choose this point, okay, it means that the ID, this is the ID value. So ID on equal to 8 not ID on, this is the VGS on, it become VGS on equal to 8 volt, and its ID somewhere here, so it is 12.5 milliampere, the ID on. Or you can choose here. Okay, so what is the VGS? It is 7. So VGS on is 7 volt and the ID on is 9 milliampere. So make sure you choose the ID and VGS on that located along this line, okay, along the curve, okay, but not this part, okay, okay. This is because this area is off area. Your transistor is in off condition, okay, off condition, sorry. So this is the on condition, okay, your transistor is on. Right, so go back to the question. Okay, I choose here 10.5 milliampere for the ID on. VGS on is 7.5 and I calculate here, I get K equal to 0.52 milli. Okay, here it's answer. Then insert this variable or this parameter, okay, for the K and then also for the VT here. So this is the equation for the curve. Okay, thank you. It's all for the question. I hope you can try and then to understand it, and if you have any question you can contact me later. Thank you.